In lesson 73, we'll be finding the integral of exponential functions other than e to the x, because we've already learned that, and the integral of logarithmic functions other than the natural log. We just studied how to find the differential or the derivative of exponential functions and logarithmic functions, and now we'll go ahead and find the integral of these types of functions. And then you should make sure you commit these integrals to memory so you know how to do those without reproducing this. So what we're going to do is we're going to start with our differential rule, or our derivative rule for exponential functions, and we know that the differential of a to the x equals the natural log of a times a to the x. And we're going to integrate both sides. When we integrate the left, the integral and differentiation cancels, so we have a to the x plus c, and we have the integral of the right side. Well, here we have a constant, so we can divide both sides. That could be factored out, and then we can divide both sides by that constant. You would also divide c by the natural log of a, but it just gives you another c, different form. But so we just leave it as c because it's just a constant, it doesn't matter. And so here's our rule for the integral of an exponential function. So the integral of a to the x dx is simply a to the x over the natural log of a plus c. So moving on to a couple examples. Integrate 143 to the x dx. Well, we're just going to use our rule for exponentials. So what we'll have is we'll have this is equal to 143 to the x over the natural log of 143 plus c. Over here in this one, we do have an exponential. We have a to a power, but we have a composite function here, and so we realize we could guess and check, or we could use U-Substitution. So our main function is this a to a power, so we'll go ahead and let u equal x squared minus 2, which means du is equal to 2x dx. Now we go ahead and do our substitution. We have a to the u. We're substituting in for x squared minus 2. And then we have this x here, x dx. So we can take out x dx. So over here, to get rid of this 2, we could divide both sides by 2, and we would get 1/2 du. So x dx, and so here's what I'm using. You don't always have to write it out, but multiplying both sides by 1/2, you get 1/2 du equals x dx. And so we can take out x dx and put 1/2 du. It's 1/2 is a constant, so let's go ahead and put it out here. So now we have this. Our U-Substitution, now we can integrate. Well, this is the integral of an exponential function. So we have 1/2 still, and then a to the u over the natural log of a plus c. But now we can put our substitution back in. And this is a to the u. Well, u was x squared minus 2, so a to the x squared minus 2 over the natural log of a plus c. And we could have put 2. Let's actually just cross this out, and we'll put 2 in the denominator here. And there is the integral of x times a to the x squared minus 2 dx. We'll start to see these in some of the problems we've been doing that involve integrals. So this one says find the volume of a solid obtained by rotating about the x-axis. So we're going to be going around the x-axis. The region bound by the graphs of 5 to the x over 2, x equals 3, and the coordinate axes. So we have this exponential function. So here's an exponential function, looks like this. The coordinate axis and x equals 3, which we'll just put x equals 3 right here, so just so we get a rough idea of what this graph looks like. Well, I guess we'll put x over equals 3 over here. And so we want to take this region and we want to rotate that around the x-axis, and we want to find the volume of that solid. Well, what we're doing is we're going to take the volume of all these little cylinders with a thickness of dx. So what we do is we integrate, and we're going from 0 to 3 of pi r squared times the height, or the thickness, which is dx. So our r here is actually the y value of our function. Well, that y value is 5 to the x over 2. So we have 5 to the x over 2, that's our radius, squared, times the thickness, which is dx. So pi r squared h, and we'll integrate here. We'll bring the pi out. This works out nicely. This just turns into 5 to the x dx, and we just learned that the integral of an exponential is, so we still have our pi, and this is 5 to the x over the natural log of 5, and that's going to be evaluated from 0 to 3. So we have pi times 5 cubed over the natural log of 5 minus 5 to the 0 over the natural log of 5. So this is supposed to say natural log of 5. We could factor out a natural log of 5, so we have pi, should have done this before, over natural log of 5. And this is 125 minus 1, so 124. So we have 124 pi over natural log of 5, and this is units cubed. And there's our answer. We could put that in a calculator and find that approximation. But again, just using the integral of an exponential again. All right, so let's move forward to, we want to find the integral of a logarithm, log base a of x dx. Well, we used this strategy before, actually, when we were finding the derivative, is we used the change of base formula and we changed it to in terms of natural log because we're familiar with natural log. This is natural log of a is a constant, so we can bring out a 1 over natural log of a. We actually have learned this already. Hopefully you have this memorized, but here it is again. The integral of natural log of x is x times the natural log of x minus x plus c, so we'll go ahead and put that in. And so we just have 1 over the natural log of a times that. And so there is our rule for the integral of a logarithm with any base. If you forget this rule, you could actually always go back and just split it up using the change of base formula. If you remember, we used integration by parts to find out what the integral of natural log was. And so now that we have that rule, we can apply it to different ones. So here's a nice simple one. It's not even a composite function, but we're just going to be plugging in here. So we're taking the integral of log base 23 x dx, and so our answer is just going to be 1 over the natural log of 23 times x natural log of x minus x plus c. And that's it. So now you know the integral of exponentials and logarithms.